So I want you to imagine a world where artificial intelligence doesn't rely on, a few massive tech giants for its servers
Right.
or its data or even its rules of engagement. Like, picture a scenario where autonomous AI agents are just out there right now paying for their own compute power.
Yeah, just operating completely on their own.
Exactly. Training their own models, coordinating with each other, using this machine-native money. And they're doing all of this without a traditional bank account, without a corporate overlord, and completely without human intervention.
Which, let's be honest, that sounds like the premise of a dystopian sci-fi novel, right?
Totally.
Like the
Yeah.
machines just waking up and opening their own checking accounts to fund their operations.
It sounds entirely like fiction. But the reason we are looking at this today is because a massive structural wall in technology is actually forcing this to become reality.
Yeah, it's not just a thought experiment anymore.
Right? So, welcome to today's deep dive. We are unpacking a comprehensive 2026 guide titled Crypto and AI Infrastructure Convergence. And the whole premise here is that centralized AI has this fatal scaling problem, and blockchain is basically the only viable escape hatch.
The only way out.
Exactly. So our mission today is to break down exactly how and why these two technologies are mechanically fusing together to create what they call a multi-trillion-dollar machine economy.
And critically, we need to separate the actual working infrastructure from, the relentless crypto hype you usually see online.
Yes, please. So let's just jump right in. You mentioned a structural wall earlier.
Right. So the structural wall is really just the physical reality of centralized AI. To train and serve these massive language models we use today, you need tens of thousands of highly expensive GPUs.
Graphics processing units.
Exactly. And these GPUs have to run in massive centralized data centers. It requires an astronomical amount of capital and electricity.
So much electricity.
Yeah. So only a handful of companies on Earth can even afford to buy the chips and build the warehouses.
So the physical hardware is completely monopolized.
It is.
But the guide points out that the software side, like the AI itself, is evolving away from that. We are moving from these passive chatbots that just answer questions to autonomous agents.
Right. Active agents.
Yeah. Like, if I want an AI agent to go out and negotiate a software subscription for my business, or, I don't know, scour the internet to assemble a custom data set, that agent suddenly needs to be an active participant in the economy.
And that transition from passive to active is exactly where the traditional system just breaks down.
Okay.
Because an autonomous agent fundamentally requires three things to operate independently.
Okay, what are they?
First, it needs a verifiable digital identity, so, other entities know who they are dealing with.
Makes sense.
Second, it needs the ability to make high-speed, high-volume micropayments. And third, it needs intermediary-free access to data and compute power.
Intermediary-free being the key there, because, try sending a piece of code to a local bank branch to hand over a passport and apply for a business credit card.
Right. Good luck with that.
Traditional finance operates on human identity. Know your customer laws, the SWIFT network, which takes days to settle.
Oh, yeah. It's incredibly slow.
It is entirely incompatible with a machine that needs to make, like, 10,000 fractional cent transactions per second.
The banking system moves at the speed of human bureaucracy, but AI moves at the speed of the internet. And this is the real mechanical reason these fields are colliding.
It's just a pure infrastructure mismatch.
Exactly. Blockchain technology provides the exact ready-made solution for machine autonomy. Crypto offers machine-native money through stable coins and tokens.
Right.
It provides built-in incentive structures, and it offers this immutable ledger of transactions that doesn't require a human bank manager to authorize anything.
There is a quote in the source material. This is from a May 2026 letter by Pantera Capital that frames this perfectly. They wrote, AI is the new capability. Blockchain is the enabling infrastructure.
That's a great way to put it.
And the guide uses this biological analogy to map this out for you, which I love. It says, if AI is the brain, then crypto acts as both the nervous system and the wallet.
Yeah, and Chainalysis actually published an insight that builds on that exact biological mapping. They categorize blockchain as the execution and transparent data layer, while AI functions as the decision layer.
So the AI brain decides what needs to be done.
Right. And then the blockchain nervous system securely transmits that signal across the network, and the crypto wallet executes the payment.
Okay, having a theoretical framework is one thing. But the guide actually breaks down the physical and digital infrastructure being built right now to facilitate this.
The actual plumbing.
Exactly. It categorizes the space into 3 distinct pillars. And the first one attacks that massive hardware monopoly we talked about earlier, decentralized compute, or DePIN, specifically for GPUs.
Yeah. Right, DePIN. That stands for Decentralized Physical Infrastructure Networks.
Okay.
Because the centralized hyperscalers, Google, AWS, Microsoft, they hoard all the top-tier chips. So DePIN projects are trying to unlock latent, unused compute power globally.
Right.
A prime example in the text is the Render Network, or Render.
Yeah, Render is such an interesting pivot because they initially built a network for 3D graphics, right?
Yeah, for animators and visual effects.
Like if an animator needed to render a complex 4K video, instead of buying a massive server, they could tap into the Render network. People with high-end gaming computers sitting idle at home could just rent out their graphics cards, crunch the data for the animator, and earn tokens in return.
Right, but underneath the hood, the matrix math required to render a 3D explosion in a video game is actually incredibly similar to the parallel processing required to train or run an AI model.
Oh, wow. I didn't realize it was the same math.
It's very similar. So as the AI boom created the severe shortage of GPUs, Render simply expanded its network to handle AI workloads.
That is so smart.
It is. And you also have Akash Network, which operates as a decentralized cloud compute marketplace. They allow anyone with spare server capacity to bid on computing jobs, which effectively prices cloud computing significantly cheaper than the centralized giants.
But wait, let me push back on this for a second. If I'm trying to run a highly complex, data-heavy AI model, stringing together a patchwork of gaming laptops and random servers in basements across the globe, I mean, that sounds like a total latency nightmare.
Well, it absolutely would be for certain tasks.
Right, because data has to move back and forth constantly. Doesn't that fragmented hardware just crash under the weight of a major AI workload?
That is a very critical distinction to make. Training a massive trillion-parameter model from scratch, that still largely requires a tightly coupled, centralized cluster of GPUs.
So they can talk to each other instantly.
Exactly, near zero latency. But inference, which is the act of asking an already trained model a question and getting an answer, is far less demanding. So DePIN networks like Akash are currently highly effective for inference, or for fine-tuning smaller models, or running specific localized tasks where millisecond latency isn't a total deal-breaker. They segment the workload to match the hardware's capabilities.
Okay, that makes the distinction much clearer. Decentralizing the hardware solves the physical bottleneck. But, I mean, having cheap servers doesn't solve the monopoly problem if the AI models running on those servers are still controlled by 2 massive corporations.
Right. You just traded one master for another.
Exactly. The intelligence itself has to be decoupled. And that brings us to the second pillar in our guide, decentralized intelligence and models. This is where the guide highlights a network called Bitensor, which trades under the ticker TAO.
Yeah, Bitensor is fascinating. They are attempting to build a decentralized market for machine intelligence. So instead of one company building a monolithic model behind closed doors,
Like OpenAI.
right. Instead of that, Bitensor operates through what it calls subnets. These are essentially competitive microeconomies where different AI models compete to provide the best output for a specific task.
Like what kind of tasks?
It could be anything: generating code, translating languages, analyzing medical imaging. The subnets are specialized.
But here is where the game theory gets really complicated for me. The source says validators score the performance of these competing models, and then miners, the people actually providing the models, earn tokens for high-quality intelligence.
Right.
If a miner's only goal is to maximize their token payout, what stops them from just writing a script that copies the best-performing model on the network? Or just spamming garbage data to farm the rewards? I mean, how does a piece of code objectively grade another piece of code without a human teacher constantly intervening?
Well, you've just hit on it. Incentive design is the hardest problem in crypto, and you have just identified the core friction point of Bitensor.
It seems like a massive vulnerability.
It is a challenge. The validators are nodes in the network that do not produce intelligence themselves. Their sole mathematical function is to query the miners, evaluate their responses based on predefined cryptographic rules, and rank them.
Okay.
If a validator detects copied answers or low-confidence outputs, the miner's score drops and they don't get paid.
So the network has to constantly update the grading rubric to outsmart the people trying to cheat it. It's an adversarial environment by design.
It is entirely adversarial. The game theory requires the validators to be economically penalized if they grade poorly, and the miners to be penalized if they perform poorly.
Wow.
It is a brilliant concept for crowdsourcing intelligence, but its long-term survival relies entirely on the mathematical robustness of those validation mechanisms. If a loophole is found, the network degrades instantly.
Okay, so we have the hardware handled by DePIN and the models handled by competitive networks like BitandSoar. The third pillar brings this all together into actual execution: data, agents, and coordination.
The actual real-world application.
Right. And the 2026 guide points heavily toward the Artificial Superintelligence Alliance, which is this massive consolidation of 3 different projects: Fetch.ai, SingularityNet, and Ocean Protocol.
And to understand why they merged, you really have to look at the mechanical requirements of an AI agent acting in the real world.
Okay, break that down for us.
You need the agent itself, you need a secure place for that agent to buy data, and you need a broader cognitive framework for the agent to process that data.
Let's actually walk through a literal 60-second hypothetical in this machine economy for the listener, just to see how these 3 pieces actually interact.
Okay, let's do it.
Say you want an AI to optimize a complex supply chain for your small business. You deploy an autonomous agent built on Fetch.ai. Fetch acts as the procurement officer.
Right. That Fetch agent goes out into the digital marketplace and realizes it needs real-time global shipping data to solve your problem.
But that data is proprietary, right? It's not free.
Exactly. So the Fetch agent interacts with a smart contract on Ocean Protocol. Ocean operates as the secure, tokenized warehouse for that data. The Fetch agent pays the Ocean smart contract using a stablecoin.
The smart contract mathematically verifies the payment, unlocks the dataset, and hands it over to the agent. No human invoices.
No credit card processing fees.
Just a machine-to-machine transfer of value for data in seconds. And then SingularityNet acts as like the executive strategy board, providing the deeper AI models that the Fetch agent uses to actually analyze that newly purchased data.
And then it delivers the supply chain optimization back to you. It functions as an autonomous corporate supply chain.
That is mind-blowing.
It is. And the guide notes several other major players building out similar execution environments. Near Protocol is heavily optimizing its chain to act as the base settlement layer for these AI transactions.
Right, the blockchain for AI narrative.
Exactly. Beta Network is utilizing its edge cloud to provide distributed GPU nodes specifically for video and media AI tasks. And Internet Computer is attempting to host AI models directly on its blockchain so smart contracts can interact with them natively.
So the theoretical infrastructure is massive.
Yeah.
But if you are listening to this, you're probably wondering if this is just more white paper vaporware or if real money is moving through these systems today. Like, we have to look at the actual adoption.
Oh, the guide is very clear that we are well past the speculative white paper stage. Real institutions and enterprises are utilizing this hybrid infrastructure right now.
Really? Like today?
Today, universities and research labs are actively plugging into networks like Akash and Render to run inference on their models because the economics demand it.
Right. They aren't doing it because they have some philosophical loyalty to decentralization.
Oh, definitely not.
They are doing it because an Akash compute node might cost a fraction of what an AWS node costs per hour.
Economics is the only true driver of enterprise adoption. And on the academic side, the foundation for this was laid years ago. There's a 2022 study by Singh and his team which thoroughly documented this synergy.
Oh, yeah, I saw that in the guide.
They proved mathematically that blockchain serves as the optimal, reliable data infrastructure, while AI serves as the decision optimizer.
And traditional finance is completely caught on to the math. I mean, the most staggering statistic in this entire guide comes from Franklin Templeton.
This is the big word.
They project that by 2030, we will see $3 to $5 trillion in agentic activity.
That is $3 to $5 trillion of economic value generated purely by autonomous software agents doing business with each other, negotiating contracts, trading assets, and buying compute power.
An economy the size of a major sovereign nation, completely devoid of human intervention.
Which is exactly why institutional capital considers this the dominant investment theme of 2026. If machines are generating nation-state levels of GDP, they require a native financial rail.
That makes perfect sense.
But, and this is important, the guide issues a massive warning here for you. Because the total addressable market is in the trillions, the space is flooded with absolute garbage.
Of course. The crypto grift.
Right. You must look for projects that show verifiable engine metrics. Look for verifiable GPU utilization, verifiable data exchanges, and active developer ecosystems. Do not buy into a speculative token simply because the marketing team slapped the letters AI on their website.
Good advice. Which brings us to the necessary reality check. If the economics are so good and the technology is actually functioning, why is AWS still pulling in billions of dollars a quarter? Like, why hasn't this completely gutted the traditional tech monopolies already?
Because building a parallel financial and computational system is incredibly messy, and there are severe roadblocks. The most prominent technical hurdle outlined in the guide is the problem of verifiable compute.
Okay, verifiable compute. Because blockchain operates on a trustless system. You don't trust the node on the other end of the transaction. You rely on cryptography to prove they executed the code correctly. But applying that level of mathematical proof to an AI model, I mean, that seems computationally devastating.
It is orders of magnitude heavier. When you run a large AI model, millions of weights and parameters are changing simultaneously.
Right.
To cryptographically prove to a blockchain that the model executed every single calculation correctly, using things like zero-knowledge proofs, it requires an enormous amount of overhead. The cryptographic proof can sometimes take longer and cost more to generate than the actual AI computation itself.
So what does this all mean? It's like the equivalent of buying a $5 burger at a restaurant, but the health department requires the restaurant to legally and scientifically prove they cooked it exactly to the recipe down to the molecular level.
That's a great analogy.
Suddenly, the restaurant has to pass that legal and scientific overhead onto you, and your $5 burger costs $50 and takes 3 hours to make. At a certain point, you just want to eat, and you're willing to trust the chef to save time and money.
And that is exactly what enterprise clients are doing today. Until the mathematical overhead of zero-knowledge proofs and verifiable compute drops significantly, most heavy computation will remain off-chain in trusted environments.
Makes sense.
Users will just choose speed and cost efficiency over perfect cryptographic verification.
Which feeds directly into the second major roadblock. The hyperscalers still have the advantage of stability. I mean, AWS, Google Cloud, Microsoft Azure, they are centralized, but they are incredibly reliable.
Yeah, if you are a hospital network deploying an AI to analyze live patient diagnostics or, I don't know, a financial firm running high-frequency trading algorithms, you require absolute zero latency and rock-solid uptime.
You can't afford a glitch.
Exactly. Decentralized networks, relying on disparate hardware globally, introduce variability. For a massive enterprise, the risk of a decentralized node dropping out completely overshadows the marginal cost savings. They will gladly pay the AWS premium for the guarantee of stability.
There is also the glaring issue of data privacy. We talked about Ocean Protocol tokenizing data, but broadly speaking, if an AI is going to act as a personalized agent for you, it needs your calendar, your financial history, your email.
All your private stuff.
You cannot put sensitive, personally identifiable information on a public ledger for distributed nodes to crunch.
No, absolutely not. Training decentralized AI on private data without leaking that data to the network validators remains a largely unsolved problem.
Is anyone working on that?
There are advances in fully homomorphic encryption, which allows AI to process data while it is still encrypted. But, much like verifiable compute, the mathematical overhead makes it currently way too slow for widespread commercial use.
But the most fascinating roadblock in this 2026 guide isn't technical at all. It is entirely legal. If we have a multi-trillion-dollar machine economy, the regulatory and liability frameworks are just a massive blind spot.
We are trying to apply 20th century contract law to 21st century machine autonomy, and it simply does not map. The unresolved question of liability is a profound friction point holding back institutional adoption.
Right. Like, let's say you deploy a trading bot, and it interacts with a decentralized model, hallucinates, and immediately loses $1 million of your company's money.
Ouch.
Or worse, the agent independently negotiates a contract to purchase data that turns out to be highly illegal or classified. Who gets sued?
There is no legal precedent. Do you sue the user who clicked deploy? Do you sue the decentralized nodes that train the model?
Right.
Or do you sue the miner who processed the transaction on the blockchain? Because the infrastructure is entirely decentralized, there is no single corporate entity to subpoena.
So the technology is rapidly outpacing the legal system's ability to even comprehend it.
By leaps and bounds.
So when you look at all of this together, the hardware monopolies forcing AI onto the blockchain, the creation of autonomous agents paying for their own data, and the massive hurdles of compute overhead and legal liability, what is the actual takeaway for you listening to this deep dive?
The core thesis of the guide is that the convergence of crypto and AI is not going to replace OpenAI or Google Cloud overnight. It is not a zero-sum game.
Right.
What is actually happening is the construction of a robust parallel infrastructure. It is an alternative open source path where machines can operate natively, preventing a future where all artificial intelligence is bottlenecked and controlled by three corporate boardrooms.
It is basically giving the AI brain its own nervous system and its own wallet.
Beautifully said.
But navigating this space requires a high degree of critical thinking from you. You have to look past the trillion-dollar projections and focus relentlessly on the mechanics. Are real developers using this network? Is there verifiable demand for the compute power? Ignore the hype. Audit the infrastructure.
Yeah. Curiosity is essential, but healthy skepticism will protect your capital. Demand to see the mechanical substance of how these networks actually function before assuming they are the future of the economy.
I want to leave you with a final thought to ponder, building directly on that regulatory nightmare we just unpacked. We started by imagining autonomous agents operating completely free from human intervention.
Right.
If a piece of software can legally hold its own digital wallet, if it can execute legally binding smart contracts, and buy its own server space without a human ever signing a document, what happens when that machine commits a financial crime?
Oh boy.
If the agent goes rogue and bankrupts a business, does the machine itself declare bankruptcy? Do we shut off its access to the DePIN servers as a form of digital imprisonment? Or does this inevitable convergence mean that in the very near future, the court's going to have to legally define personhood for a string of code?
That is the ultimate question this convergence forces us to answer.
It absolutely is. Thank you for joining us on this exploration of the machine economy. Keep questioning the mechanics, look for the actual substance, and we will catch you on the next deep dive.